So we have done the advertisement in router 1. In router 2, I'm going to advertise the same. That means from router 1 here, that is 10.0.12 is a network what I'm advertising on serial 0/0 interface. So from here, my hello packet will be sending to this interface. So what the first step requirement is, the interface which is going to receive the hello packets, that should be in the same subnet first of all. That means here 10.0.12 in the sense, here also it should be 10.0.12. Otherwise it will not receive only first of all, because they are from the both are from different subnets, so they are directly connected. So they will not identify these two different subnets, so directly it will get rejected. So once this got established, that means this got uh, okay, up to the mark, that means they are both on the same subnet, then it will be checking the AS number from the hello packets what it has received. So both should be in 100. If it is not 100, again the neighbor relationship it will not be formed between the routers. So you should be very clear. So in router 2 now I am going to do the same thing. So router EIGRP 100, I'm going to advertise the network what it should get advertised in EIGRP. I'm not simply advertising all the networks. So whenever you're advertising only the required subnets, you need to advertise, not all the networks. Okay. So here I am advertising my loopback also. Why? Because I need to ping from router 1 loopback address to router 2 loopback address or router 4 loopback address. So they are the one hop away from that router, right? For that confirmation, I have given the loopback address here. So let's go and advertise remaining things. 10.0.24.0. I'm sorry, I have made a small mistake here. It is not dot 2, it is dot 0. So again, network 10.0.24.0, 0.0.0.255, network 2.2.2.2, 0.0.0.0, no auto summary. This must be enabled. Why? Because EHRP its default behavior, it will summarize the route. So fine. So let's go to router 3 and advertise our network. So I have in router 3, you can see here. So network, it is network 10.0.13.0, 0.0.0.255, network 10.0.34.0.0.0.255. Okay, now here I'm not going to advertise my router 3 loopback address. Okay, so that so there will come to know, if we not advertise what it will happen, if you advertise any network, what it will happen. Okay, for that purpose I'm leaving here. So let's go to the our next router. No auto summary. Okay, so let's go to router number 4. Here I'm going to advertise all my networks including my loopback IP address. First it is 10.0.24.0, 0.0.0.255. Then it is network 10.0.34.0, 0.0.0.255. Network 4.4.4.4, 0.0.0.0.0. That's it. Yeah, I think here you can see some logs we have got it. See, this is called the, see, dual. It is the protocol which EIGRP is using. Okay, so neighbor change notification we have got it. That means we got a new adjacency with the neighbor 10.0.24.2. Okay, how to check what are the how many neighbors I have in this routers. So before checking that, by saying only we can tell that for router 1 how many neighbors I will be having. See here, router 1, router 3, router 4. Three routers I have, right? But for router 1, there will be only two neighbors, those who are directly connected. Router 4 is not a neighbor to R1, but still he will be receiving the routes which are advertised from R4 via R2 or via R3. Okay, so let's go on. I'll show you that. Show IP EIGRP neighbors. Here we can see the two neighbors. One it is 10.0.13.3, that is the router number 3, and the next one is the router number 2. Here you are having some numbers, right? It is nothing but for example, if I have one more router, I form a neighbor relationship. I'm making some configuration so that my router is going to form a neighbor relationship with that new router. The number will get incremented. It is by uh, one by one. That means which is first from a neighbor, which is second from a neighbor. Like that, from the zero it will be start incremented. Here we can get the uptime. That means this neighbor up since 2 minutes 7 seconds. The next one it is 2 minutes 58 seconds, and this whole time that is 9 4. Once our neighbor relationship established between the router, they will be having something called keep alives. Okay, so when the keep alives are not received by the router, it will be wait. That means it is not directly going to kill that neighbor relationship until this whole timer get expired. When it come to, you can see here, I will show you. See, you can take the first uh, router 3 neighbor relationship from 12, 11, 10, 9, again it got 14. So your keep alives or keep on exchanging between the routers. That is why it is happening. So when it is coming to 0, that particular pair will be erased from your routing protocol process. Fine, so let's go to router 2 and verify it. Show IP EIGRP neighbors. I got two pairs, that is two neighbors, sorry. So show IP EIGRP neighbor. Again here I got two neighbors in router 4. Show IP EIGRP neighbor. Here also I got a two pairs, sorry, two neighbors. And okay, if we go to routing table, that is forwarding table database, show IP route, it will show you the routes learn via EGP and also the connected routes, that is locally connected. So here we are getting something called D, right? What is this D? Here see, in the sense it is a connected, it means connected. This D, what it means, you can see here, EIGRP. So actually for static it will be S, for connected it will be C, and for RIP it will be R, for BGP it will be B, for OSPF it will be O. Then why for EIGRP it is not E, why it is D? For why it is not E in the sense, in early days we are having one routing protocol by the name of EGP. So for that they have given the that E letter is reserved for that, so they can't use it. So people come to a conclusion we can use D. Why? Because D is nothing but the dual algorithm which is used by the EIGRP, not by the any other protocols. So D here mentioned the dual algorithm and the routes which are learned via EIGRP. Fine, and we are having 2222 and 4 network, which is loopback of router number 4, which is learned via router 3 and also router 2. See here, so it is going to be our primary path and it is going to be our secondary path. Okay, so what I have told in first video, EIGRP uses dual algorithm, and dual algorithm it determines the backup loop free path. So there is some condition I'll show in coming videos. So only that condition, if it is matches, it is going to put that into the routing table. Otherwise it will not put into the routing table. It will be in the EIGRP database only. Okay, so just we'll see some simple things here. So one in coming videos we will see everything in with some advanced configurations. Yeah, fine. So I think we have got loopback of 4, loopback of 2, and loopback of from router 1 only there. But I didn't receive the router's 3 loopback address. Why? Because I didn't advertise in the EIGRP. And apart from that, you can see here 24 and 34 I have received. So end-to-end reachability I have. If you want, I can ping from here 4.4.4.4. I can ping with the source. If I want loop back, still I can able to ping. Why? Because even router 4 knows what is my loopback address, because I have already advertised. Because router 4, it has how to reach 1111, show IP route, you can see here. So it has a path how to reach 111. That's what when I give sources a loopback also it can able to reach. But if I try to reach 3.3.3.3, we can't reach. Why? Because it is not there in our routing table. So what we need to make to ping 3.3.3.3, let's go to router 3, configure terminal, EIGR, sorry, router EIGRP 100 network 3.3.3.3 0.0.0.0 exit. Now I have advertised loopback of router 3 also. Show IP route. Now you should get, yeah, you got it. See here. Now you can able to ping 3.3.3.3 even from your source loopback reader. See. Thank you for watching. Stay tuned for upcoming videos. Bye.